AP Style Free Response Problem 15. An environmental concern is the depletion of O3 in Earth's upper atmosphere, where O3 is normally in equilibrium with O2 and O. A proposed mechanism for the depletion of O3 in the upper atmosphere is shown with a step 1 here and step 2. 1, write a balanced equation for the overall reaction. 2, identify the catalyst in the mechanism and justify your answer. 3, identify the intermediate in the mechanism and justify your answer. 4, if the rate law for the overall reaction is found to be rate equals K times concentration of O3 times concentration of Cl, determine A, the overall order of the reaction, B, the appropriate units for the constant K, and C, the rate determining step of the reaction. Justify your answer. All right, so first we're asked to write a balanced equation for the overall reaction. So we can add the two steps together to cancel out the Cl and the ClO, which appear on both sides of the equation, and the resulting balanced equation is O3 plus O produces 1, 2, O2. Identify the catalyst in the mechanism. So a catalyst is first appears as a reactant and then in a future step shows up as a product. So the catalyst is Cl, since it is a reactant in the first step and a product in the second. It is unchanged by the reaction. And then identify the intermediate. So an intermediate is something that is produced and then consumed but doesn't appear in the overall reaction. So that would be ClO, since it's a product in the first step and a reactant in the second. 4, if the rate law for the overall reaction is found to be rate equals K times concentration of O3 times concentration of Cl, determine A, the overall order of the reaction. The overall order of the reaction is 2. It is the sum of the two exponents. So the exponent here is 1, the exponent here is 1, and 1 plus 1 is 2. B, the appropriate units for the rate constant K. The units are molarity to the -1, seconds to the -1, to yield a rate of molarity per second when multiplied by both concentrations. So the rate is molarity per second. Then we have K, and then this is molarity, and this is molarity, right? So what does this K have to be in order for this side to equal molarity per second? It would have to be on the bottom 1 molarity and 1 seconds, because then when we multiply here, one of these cancels and I'm left with molarity per second equals molarity per second. So the units are 1 over molarity seconds, or molarity to the -1, seconds to the -1. All right, C, the rate determining step of the reaction. Justify your answer. The first step is the rate determining step. So this first step is the slow step. And how do we know? Because the reactants both appear in the rate law with exponents which match their coefficients.